Hello, everybody, and welcome to another wonderful lesson with Mr. Wheezy. So we're picking up where we left off here with proving triangles similar. So last lesson we really just kind of got into what makes different polynomials similar. What can we do to show that similar? Which, number one, we have to have all the sets of corresponding angles be congruent. The other part of that is the corresponding sides, the sides that match up, have to be proportional. And that's really what we're doing with this kickoff. I'm going to skip over this kickoff. You can always look at yesterday's if you want to know how to do that. But starting to get into, well, why can things be similar? So we are going to get into, we're going to dabble a little bit with proofs, but it's not a whole lot. It's not like what we've done the last how many chapters. So don't get too excited. But starting off here, we have postulate 7.1, which is angle-angle similarity. As long as we know there are two sets of angles that are congruent, we know that this shape is then going to be similar. So last lesson was all about, okay, this is all we have to know. Now we're starting into those, okay, what's the least amount of information do we need to know in order to say that these things are similar? So if we know that two sets of angles are congruent, we can say they're similar. Now, notice postulate, don't have to prove it, but we can use it here. So, why are these two similar? Well, right now we have an angle that's 45, so that one would work with this one over here. We know those two are congruent. Do we have enough to say that, well, these are going to be congruent by that AA similarity? Well, yeah, we can. If we look here in the middle, these here are vertical angles. So this one and this one will also be congruent. Two sets of angles are congruent, so we can say yes by AA similarity. Again, little squiggle, similarity, squiggle with equal, congruent. We do have a theorem here now. Theorem 7, which was the side angle side similarity. So if an angle on one triangle and an angle on the second triangle, and then those sides including the two angles are proportional, then the triangles are similar. So we have one set of angles that are congruent, and then the angles, or not the angles, the sides on either side of that angle is what that's meaning. If those are going to be proportional with its corresponding side of the other one, then we know that those are going to be congruent. Or not congruent, similar, sorry. So we can prove this. Now, I'm going to give you kind of the shortcut version of this. Basically what they're going to do is they're going to make a line that is parallel with this bottom, and yet will have the same distance as those. So you're really putting that same triangle in. Well, if these are congruent, these would be corresponding, and these here would be corresponding as well. So you would have three sets of angles. If I mark those, let's see, this is the double, this is the triple. So you have your three sets of angles, and then if these are the same, these would be similar, which is what they would show with given proportion, that from here to here would be the same as from, so if I call this X and this Y, from Q to X is the same thing as A to B, which is going to be, if we do this in a proportion, QX over QR would be the same thing as QY over QS sort of thing. So you get into similar proportion that way. So it involves a construction here. That's the gist of that proof, is by construction we would draw a line that's parallel, same distance, so you're really using the same triangles. By corresponding angles, we'd have congruent angles, so all the angles are congruent, the sides are proportional. We would know enough. Next, we have side-side similarity. So this is another one of those where if the corresponding sides of two angles are proportional, then the triangles are similar. So if all we know is the sides are proportional, that's going to be enough to show that these are congruent. And I am off the screen, I am sorry. So if all the sides are congruent, we'd be able to say they're going to be similar then. So really what this is going to do, knowing that you have one set of angles, R and V, which I'm not sure where V is. That must be a typo. That is my bad. I'm going to go R and B. So if we know that all the corresponding sides are proportional, we would have that part covered. What we would need to find then is how could we get the angles to be again, and it's the same sort of idea of you would draw the line in so that it's parallel. These are going to be the same length. This here's the same length, so you get corresponding angles. So then you get all your angles congruent, and that's kind of the shortcut way to proving that. Because we're not in school, it's kind of hard to get through all the proofs and hit all your questions one at a time. That we'll just kind of skip over these a little bit. These are ones that we'd really go step by step and take a long time to get through, just to make sure you understand it. But again, with not being in class and where I can't hit your directions or you hit your questions directly, we'll just keep them kind of vague. But just know that those are provable. But if you really want me to go through the exact proof, let me know. I can post that. You just gotta tell me. So why, and this should be must, the triangles be similar. So we have some sides here that we can't really see. Starting with this is Y, if you can't quite see it, and this is Z, and this here is an 8, just so you can kind of see that. But why must these be similar? Well, side, angle, side, similarity, because we would have an angle that's congruent in between them. 3 to 4 and 6 to 8. Well, 6 to 8 we can reduce down to 3 and 4, so then they'd be proportional. So that's why you get your side-side similarity. If the triangles are similar, find DE. Well, in order for these to be similar, what do you know? Well, all of the corresponding sides have to be proportional, so we can start matching things up. So bottom side here of 16, bottom side of the other one would be 24. So we're missing DE. So DE would match up, and this should be on the bottom. DE's on the bigger triangles, so think bigger's on the bottom, small triangles on the top. So DE's the bigger side, we don't know. AC is what it would match with, which would be 10 on that other side. So we would go through and cross multiply and solve. So 16x would equal 240. And if you divide by 16, now we could have reduced this to begin with, and what would have got 2/3. We could have done that too. Cross multiplying, it'll do the same thing, but x is going to end up being 15. So, last thing here, this is a more well-known problem in the math community, I don't know what I'm going to say, in the math realm, but the flagpole problem. So the height of a flagpole is unknown. However, the shadow it creates is 40 feet long. A person who is 6 foot tall casts a shadow that is 8 foot long. How tall is the flagpole? So what this is really representing is ways that we can measure things that we can't just walk up and hold the measuring stick to and be able to measure it out. What are some other ways we could do it and still get that measurement without having to try and find some way to climb up there and get that all measured? So what we're doing is we're going to set this up with a proportion. So start with the person. So they're actually 6 foot tall, and they make an 8 foot shadow. So think height shadow. On the other hand, we have the flagpole. So let's just put pole. So the actual height of the flagpole, we don't know. But we know it makes a 40-foot shadow. And that's how we're really making this proportion. So if our height's on top, shadow on the bottom, we're going to do that. Person on the one side, pole on the other. Put them in the same spots, and then we're multiplying stuff out. So cross multiply there. And so 8x would equal 6 times 40, which would be 240. And divide by 8. So x is going to end up being 30 feet. So that is it for this lesson. Any questions, comments, concerns, please feel free to message me. Again, Google Classroom, email are going to be the best. I check those the most often. And then you can always pay me too, but I just don't check it as often. All different ways you can get a hold of me. Send me questions. Let me know what's going on. And we'll go from there. So until next time, we'll talk to you later, guys.